for a continuous system? Ixx for the continuous system? Ram, can you please tell me? कंटिन्यूअस सिस्टम के लिए Ixx कैसे लिखोगे?
सर इंटीग्रेशन डीएम
वेरी गुड, वेरी गुड. इंटीग्रेशन डीएम
वाई आई स्क्वायर प्लस जेड आई स्क्वायर.
नहीं, इसमें y i का कोई रोल नहीं होगा ना, बिकॉज थिंग इज कंटिन्यूअस. ओके,
यस.
वेरी गुड. सो इसे आप इंटीग्रेट कैसे करोगे? हाउ यू विल इंटीग्रेट इट? आप इसे इंटीग्रेट कैसे करोगे? इंटीग्रेट करने यहां तो वेरिएबल y और z है, तो हाउ यू विल इंटीग्रेट इट? और लिखा हुआ है डीएम. Minal, can you please tell me how you will integrate it?
So by making it the function of y and z by using the concept of mass density.
Okay, suppose this will be in a three-dimensional system. Then dm can be written as a function of y or z or x, y or z?
So then it will be written in x, y, z.
X, y, z actually. Actually, you have to use the concept of mass density.
Density.
है ना? So what is density? Mass per unit volume for the three dimension. Mass per unit area for the two dimension. Mass per unit length for the one dimension.
One dimension.
Okay, so हमें इस तरह से करना पड़ेगा. Very good, very good, good. So let's try to go for some basic problem. So let's try to go for this one. So we have, this is my origin. So this is along x-axis. So this point is A and 0. This is x-axis. This is y-axis. And here is mass m is there. And here is mass 2m. And this will be your A and A. And there is mass 3m. And this will be something like minus A and A. And there is mass 4m. And that value is equal to minus A and A. So these are coordinate of xy plane. Okay. So these are coordinates of xy plane. So what we have to do? We have to just write the moment of inertia tensor. Okay. So we have to just write the moment of inertia tensor. And अच्छा ये बताओ, ये अगर only x and y दिया हुआ है, then your moment of inertia tensor will be 2 cross 2 matrix or 3 cross 3 matrix? Anyone?
Matrix.
क्या?
Cross 3 matrix.
3 cross 3 matrix. You will always write moment of inertia as 3 cross 3 matrix. So what will happen to another coordinate? So you have to always keep in mind that if this is in xy plane, then z coordinate is always 0. So without solving anything, can you tell me which component is going to be 0 directly? कौन सा component 0 हो जाएगा?
So
IZZ.
IZZ? No, IZZ is not 0.
ZX and ZY.
Very good. What you will have? You have IXZ is equal to IZX. That is nothing but negative of summation over MI XI ZI. So every time ZI is 0, so all this term is 0. Now another term is also 0. कौन सा term होगा 0?
YZ.
YZ. Very good. IYZ is equal to IZY is equal to minus summation over MI YI ZI is equal to 0. And now we can just talk about all other term. So चूंकि ये plane में है, so these components are 0. Now let's try to calculate IXX. So what will be my IXX? The IXX is summation over MI
YI
YI square plus zi square. So every time zi is 0, so what we can write? We can go for summation over mi yi square. So what will be value? So I can just put this one is my first, this one is my second, this one is my third particle, and this one is my fourth particle. So first one is m1. What is value of m1? M. What is value of y? That is 0 square. Plus second one, 2m into a square, isn't it? Third one, 3m into a square. And what about fourth one? Sorry, this is minus. Oh, just a minute. Ye yahan nahi is otherwise unnecessary bekar. Keep it here. So minus a and 0. Sorry. Minus a and 0. Keep it here because things should be little bit well organized. Okay. यहाँ put करने का हो वहां भी रहेगा तो हम कर लेंगे. Don't worry. So this will be minus 3a square. Isn't it? What will be next one? 4m into 0 square. So what is this value?
5m.
A square.
5m a square. So this is our ixx. Now let's go for iyyy. What will be our iyyy? That is summation over mi xi square plus zi square. Isn't it? So this is your xi square plus zi square. Again your zi square is equal to 0 every time. So what you have? You have summation over mi xi square. So again we will go for that. What will be first one? M into a square. What will be second one?
2m into a square.
Very good. 2m into a square. What will be third one?
3m into a square.
3m into a square. What will be fourth one?
4m into a square.
Very good. 4m into minus a square. Actually, that means that is also a square. Hai na? You have to take minus a square, and here is minus a square. So what is this value?
10m square.
10m square. Very good. Now we have to go for what? Izz. So when I will go for Izz, that means summation over mi xi square plus yi square. Without calculating, can you please tell me what should be the value?
15m.
15. क्यों? क्योंकि आप इसको अलग अलग लिख सकते हो. That is mi xi square plus summation over mi yi square, and this is basically mi xi square is equal to 10 ma square, and that value is 5 ma square. So that is what? 15 ma square. कुछ याद आ रहा है अपनी स्कूल डेज? स्कूल मीन्स +2 डेज. अनुज बताएगा. कुछ याद आ रहा है अनुज?
Yes, sir. Perpendicular axis theorem.
Very good. This is nothing but what? Something like perpendicular axis theorem. So आप जो वहां पर काम करते थे वो बेसिकली सिर्फ मोमेंट ऑफ इनर्शिया के लिए काम करते थे. That means you are working only for the diagonal term of the moment of inertia tensor. है ना? You have ixx plus iyy is equal to izz. What is meaning of that? Your masses are confined into xy plane, and you can easily find izz. So what will be the next one? Next one हमें क्या निकालना होगा? I xy is equal to I yx, and that value is equal to summation over with the negative sign mi xi yi. So now what will be first one? Is 0, isn't it? What will be second one? 2m into a. What will be third one? And negative sign will be also there. है ना? So we will put negative sign before that. And what will be third one? 3m minus a into a. What will be fourth one? 0. If you are going to multiply it, that will be 0. So what is this value? क्या आ रहा है ये?
MA square.
MA स्क्वायर या माइनस MA स्क्वायर? क्या आ रहा है? दिस विल बी माइनस साइन
minus
Hmm?
will be
Plus MA
plus
square.
MA
MA square. You are getting what? Plus MA square, isn't it? This minus will be go there. And this will be again go there. So this will be plus and this will be minus. Am I correct? ठीक लिखा हूं ना?
Yes, sir.
Okay. So now you can write your moment of inertia tensor. The moment of inertia tensor is here. You can write Ixx. So you cannot change the thing. Okay. So Ixx is basically 5MA square. Ixy is equal to MA square 0. And that value is MA square. And what is this? Next is 10MA square. And you have 0. And what will be this? 0 and 0. And what will be there? 15 MA square. So this will be your moment of inertia tensor. Okay. So this is your moment of inertia tensor. So this is now, if I will shift the origin, then the moment of inertia tensor will remain same or it will change?
It will change, sir.
It will change. So everything is dependent on what is your origin. Okay. So this is very basic problem to just trying to understand just trying to understand how you can use the formula. But real challenge is not discrete one. Discrete one is quite simple. Let's try to go for a continuous system, which is really more challenging. Okay. So let's try to go for next problem. और next problem में हम लोग हर एक चीज करने की कोशिश करेंगे. We will just try to figure it out. What is moment of inertia? What is principal moment of inertia? As well as what will be the principal axis. Okay. ये सारा करने की कोशिश करेंगे. And next class में हम लोग बात करेंगे किस तरह से इसमें हम physics लगा सकते हैं. Means how you will find the angular momentum, how you will find the torque, how you will find the kinetic energy, all this thing. We can also do this thing here also. So there is not any problem. यहाँ तक clear है everyone?
Yes, sir.
Okay, good. चलो. So let's try to do some nice problem. And this is really beautiful problem. Chalo. So what is this? This is my y-axis. This is my x-axis. And this is rectangular sheet. Okay. So this is y0 and this is origin. The corner of sheet is at the, the origin is at the one of the corner of rectangle. So this is my x-axis. This is my y-axis. And this length is A and this length is B. And here we have constant mass distribution. Okay. So initially we will take the constant mass distribution, but your mass can be vary with X, with Y, and then you have to use little bit more calculation. But here, hence we are doing first time or first level of problems. So we are just taking the mass should be constant in nature. Okay. Now, what we have to do, we have to just figure it out. What will be moment of inertia tensor? Second thing we have to calculate, for B is equal to A, find principal moment of inertia. Third, for B is equal to A, find principal axis. And fourth, if omega vector is given by case 1, this omega is given by 0, 0 omega naught. That means we are rotating, and here is the origin. So it is rotating something like this. Then what will be angular momentum? And if omega is something like 0, omega not 0, what will be angular momentum? And once you will calculate the angular momentum, you can easily calculate the kinetic energy. So you have to also calculate what will be kinetic energy and what will be kinetic energy. So in the one problem, we will just try to solve all this thing and let's see how much time we can take. Okay. So again, by the inspection, which term is going to be 0? So
Z.
first question हम लोग कर रहे हैं. Which term is going to be 0?
IZX and IX.
Very good. So IXZ is equal to IZX is equal to 0. Similarly, we have IYZ is equal to IZY is equal to again 0. Yes. So because it is just in a plane, we will do the problem where you have this particular solid system also in the volume, the mass is distributed into volume, then obviously every component will be useful for you. Anyway, so this is my first thing. Now let's try to go for our diagonal term. So what will be IXX? So now it is continuous system. So how you will go for this? We will just try to write dm y square plus z square. But every time, what will be your z?
0.
0. So this is equivalent to dm y square. Yes, are you people agreed? So this value is equal to what? Dm y square. Now, the whole thing is that how we are going to integrate it. So obviously, we will use the concept of density. So here, your mass is confined into a area, isn't it? Mass कहाँ confine हो रहा है? Area के अंदर. So, can I write m upon AB mass per unit area will be, so density is constant, can be easily written as dm by dx into dy. What we can do, we can take a elemental mass that is nothing but dm at distance x at distance y of the width dy and dx. ले सकते ना ऐसा? x एक छोटा सा आप एरिया ले सकते हो. Are people able to understand this thing or not?
Yes, sir.
Yes. So this is your thing. So now from here we can write dm is equal to m upon ab dx into dy. So here you can see y square is there, but we have to integrate it. So this will be the double integral or single integral or triple integral? Double integral. That will be double integral. And if the mass was confined into volume, then you have what? Single integral, double integral, or triple integral? Triple integral. Very good. So here we have to go for double integral. Now you can see we can replace my dm with dx into dy. This is the real challenge to solve your problem. How you are replacing your dm as a function of dx and dy. Okay, so my IXX is basically integration of m upon AB, and here we have dx dy into y square, and we have to go for double integral. So we can go for and this problem is very simple. So you will go for x is going to what? 0 to a. And we will just go for m upon AB, and here we have dx. And what about y? There is variable y, dy, and you are going from where to where? 0 to b. So from here, IXX can be written as, so what will be value? So if I am not wrong, that value is mb square by 3. सही है ये?
Yes.
Yes. A and A is cancel out, and this will be cube is there by 3. So 1b is cancelled out. So mb square by 3. Now, can you please tell me what will be IYY without doing integration?
MA square by 3.
MA square by 3. So once you and always try to see the symmetry. एक integration करने के बाद दूसरे को आप direct लिख सकते हो, है ना? Unless until very complicated thing are not there, unless until you cannot identify the symmetry, that is different issue. But in general, what you can do, you can easily write all this thing. Okay. So this IYY is equal to M A square by 3. Now, can you please tell me what is IZZ?
M by 3 A square plus B square.
Very good. So how? Because you will write dm x square plus y square, and this IYY is nothing but dm x square plus z square. You will put z square is equal to 0, then you will get this thing. So this will be something like addition of both this thing. So what will be IZZ? IZZ is equal to m by 3 a square plus b square. ठीक है ना? Okay. Chalo. So let's try to go for a final thing. What will be final thing? IXY. IXY is equal to IYX. चलो फटाफट निकाल कर बताओ क्या आ रहा है. Take your time. What is formula here?
Minus integral dm.
dm(xy). Okay. And again you can write dm minus m upon ab, and here x dx, and here y dy, 0 to b, 0 to a. So that value is minus m
AB by 4.
ab by 4. Okay. So this is our whole thing. Now we can easily write moment of inertia tensor. यहाँ तक क्लियर है? किसी को कुछ पूछना है किसी इक्वेशन में, कोई इंटीग्रेशन में? दिस इज वेरी सिंपल, नॉट वेरी टफ. बहुत ही आसान है, तो आप इजिली इसे कर सकते हो. यस, ओके. Chalo. So let's try to go for, and what is my moment of inertia tensor is what? M b square by 3 minus m ab by 4. This term is 0, and that value is again m ab by 4, and this is m a square by 3, 0, 0, 0, m by 3 a square plus b square. So this is your moment of inertia tensor. Okay. So now what we have to do? We have to just find the principal moment of inertia for b is equal to a. Okay. So when we will go for b is equal to a, then I can write my I is equal to m a square by 3 minus ma square by 4, means that will convert it into square, isn't it? And that value is minus ma square by 4 ma square by 3, 0, 0, 0, 2 by 3 ma square. Clear है ये? So now we have to calculate what? Principal moment of inertia. So when we have to calculate principal moment of inertia, what you have to do? You have to just write the secular equation. What is secular equation? I minus lambda u is equal to 0. And what is u?
Unit metric.
Unit matrix. So I can write minus lambda here, minus lambda here, minus lambda here. That must be equal to 0. And I can expand this thing about this अबाउट दिस पॉइंट है ना, इसके अबाउट एक्सपेंड कर सकते हैं. सो व्हाट यू विल हैव 2/3 ma square minus lambda, and here you can easily go for ma square by 3 minus lambda whole square minus ma square by 4 whole square, that must be equal to 0. Yes, है ना? So this is just a square minus b square, so you can easily use first thing. So you have lambda 1 is equal to ma square by 12, है ना? a minus b into a plus b कर सकते हो ना? देखो आ रहा है ये. Lambda 2 is equal to, if we can just add it, then that will be 7 ma square by 12, and lambda 3 is equal to obviously 2/3 ma square. 2/3 ma square. So this is your lambda 1, lambda 2 and lambda 3. Clear है ये? देख लो, चेक करो.
So,
Hmm.
so please explain the third step.
थर्ड वाला
जी.
इसको 0 करोगे तो क्या आएगा? नहीं आएगा. इसे किया a minus b into a plus b, नहीं.
सर हमने वो सेक्युलर इक्वेशन से डिटरमिनेंट फॉर्म में ले आए सबसे पहले.
सेक्युलर इक्वेशन तो यही होता है, इसका डिटरमिनेंट ही होता है ना. हाउ यू विल फाइंड द आइगन वैल्यू? डिटरमिनेंट ऑफ दिस मस्ट बी इक्वल टू 0, isn't it? Huh? Secular equation is all about determinant,
यस सर.
है ना? So we are just using this thing. कुछ गड़बड़ है क्या? कहाँ समझ में नहीं आ रहा है? Now you are okay?
हाँ सर, नाउ आई गॉट इट.
So I am just expanding about this axis because I have 0 zeros, then I can easily expand. है ना? आपको हमेशा ये देखना चाहिए कि जिसके अबाउट 0 0 है उसी के अबाउट एक्सपेंड करो ताकि आप डायरेक्टली उसे लिख सको, है ना? So this is very important.
ओके.
Okay, chalo. So now we have to figure it out. And what is this? This thing is identified as what? Principal moment of inertia. Principal moment of inertia. Okay. Suppose you will diagonalize this moment of inertia tensor, this one, then what you will get into the diagonal term? बताइए. If you will diagonalize this moment of inertia tensor, then what you will get in the diagonal term?
Sir, lambda to ma square I'm getting, sir. It's not 7 ma squares.
First one is ma square by 12.
Okay, sir. 40.
And,
okay, sir.
And second is 7 ma square by 12. And third is 2 ma square by 3. Okay? Are you getting
Yes,
this
sir.
thing?
Yes, sir. Same. Okay,
Good.
sir. Thank you.
Good, good. Very good, very good. If you are doing with yourself, you are just moving towards success. Okay? The most important thing is that you have to solve with me. Not just try to take the notes and make the copy of this thing. Try to solve it. Okay? Good. This type of doubt is very relevant. Okay? Now, let's try to go for... Now, अभी तो आपने मेरे आंसर ही नहीं दिया. चलिए बताइए क्या होगा अगर मैं इसे डायगोनलाइज करूंगा. Then which term will be in the diagonal term?
Principal moment of inertia.
Principal moment of inertia. Very good. And you know this from this, the property of matrices. Property of matrices से आपको ये पता होना चाहिए कि अगर आप किसी भी matrices को, and especially if it is symmetric matrix and it is diagonalizable, then what you can have principal moment of inertia in the diagonal term. And कहां पर कौन सा term होगा, that will depends on in which basis you are going to diagonalize it. तो हम इसको किसके बेसिस में हम इसे डायगोनलाइज करना चाहेंगे? Just tell me. In which
Yes.
basis you want to diagonalize it? किसके बेसिस में इसे डायगोनलाइज करना चाहोगे? ऑब्वियसली अबाउट प्रिंसिपल एक्सेस, है ना। अगर आप किसी भी मैट्रिक्स को, जस्ट राइट डाउन दिस नोट्स, दिस लाइन, इफ एनी मैट्रिक्स विल बी डायगोनलाइजेबल in a basis of eigenvector, then the corresponding eigenvalue will be in the diagonal term. Are you getting my point? Okay.
Please repeat this line.
मैं ये कह रहा हूं, if any matrix which is diagonalizable and it is diagonalized in a basis of eigenvector, then the corresponding eigenvalue will be in the diagonal term. समझ रहे हो मैं क्या बोल रहा हूं? मीन्स मेरा कहने का मतलब यह है कि आपके पास लैम्डा 1 है और इसके करस्पॉन्डिंग आपको x1 आइगन वेक्टर आया है, लैम्डा 2 है आप इसे x2 कहते हो, और लैम्डा 3 है आप इसे x3 कह रहे हो। और आप अगर इसे x1, x2 और x3 के बेसिस में लिखो, इसके बेसिस में लिखोगे, तो डायगोनलाइज होने के बाद जो डायगोनल टर्म आएगा वो क्या आएगा? लैम्डा 1 0 0 0 लैम्डा 2 0 0 0 लैम्डा 3। और अगर आपने बेसिस चेंज कर दिया, अगर x1, x3, x2 लिखा, तो क्या हो जाएगा बता सकते हो?
So lambda 1 0 0
वेरी गुड, लैम्डा 1 0 0 0
0 0 0 lambda 3
0
तो
लैम्डा
X3 है ना?
3 0 एंड 0 0
lambda 2
लैम्डा 2। ओके, और ये जो वेक्टर है, एंड व्हाट इज दिस वेक्टर? दिस इज जस्ट अ स्क्वायर मैट्रिक्स, है ना, ये वेक्टर के फॉर्म में लिखा है, सो दिस विल बी स्क्वायर मैट्रिक्स, यू कैन इजिली डायगोनलाइज दिस थिंग। आर यू गेटिंग माय पॉइंट? सो व्हाई वी हैव प्रिंसिपल एक्सेस, इसी कारण हमें प्रिंसिपल एक्सेस की जरूरत होती है। ओके, बिकॉज यू कैन डायगोनलाइज योर मोमेंट ऑफ इनर्शिया टेंसर, और डायगोनलाइज होने के बाद आपका एक्स एक्सिस, वाई एक्सिस, जेड एक्सिस जो है 1 0 0 0 1 0 एंड 0 0 1 हो जाएगा। ओके, एनीवे चलते हैं, अभी कुछ प्रॉब्लम करते हैं, फिर इसको हम और भी डिटेल में डिस्कस कर सकते हैं। लेट्स ट्राई टू कैलकुलेट द आइगन वेक्टर और प्रिंसिपल एक्सेस। चलो, मैं आपको होमवर्क दूंगा, तो आप ये प्रैक्टिस करोगे तो आपको समझ में आएगा। नहीं समझ में आएगा, देन आई विल जस्ट डिस्कस इनटू द नेक्स्ट क्लास, डोंट वरी। सो लेट्स x1 की वैल्यू मैं पुट कर रहा हूं, x1, x2, x3, ठीक है। दिस इज माई आइगन वेक्टर corresponds to ma square by 12. okay, so what you have I x1 is equal to lambda 1 x1. This is your equation of eigenvalue and the eigenvector, है ना। What is your I बताइए क्या है? फर्स्ट टर्म क्या था? ma square by 3। सेकेंड टर्म क्या था? माइनस ma square by 4, दैट इज 0। ये क्या था? माइनस ma square by 4। यहां क्या था? ma square by 3, 0 0 0, एंड दिस विल बी 2 by 3 ma square, है ना। सो मैं इसको ऐसे लिख सकता हूं, x1 और स्मॉल में लिखा है तो x1, x2, x3, किसके अबाउट निकाल रहे हो? लैम्डा 1 हमने क्या रखा है? ma square by 12, है ना। सो दैट इज ma square by 12, you have x1, x2, x3। क्लियर है ये? यस, नाउ वी हैव टू सॉल्व इट। अब हम जब इसे सॉल्व करेंगे, देन व्हाट यू विल गेट, चलिए, सो यू हैव टू सॉल्व इट। सो ma स्क्वायर तो हर एक जगह पर कैंसिल हो जाएगा। सो व्हाट यू विल हैव, 1/3 x1 minus 1/4 x2 is equal to 1/12 x1. लिख सकते हैं इसे? यस या नो? देख लो।
Yes, sir.
ठीक है ना? सेकंड वाले से भी देखो, एंड थर्ड वाले से क्या आएगा? सेकंड वाले से क्या आएगा? माइनस 1/4
x1
x1 प्लस 1/3 x2
X2.
इज इक्वल टू 1/12 x2.
X.
और थर्ड वाले से क्या आएगा? When you are going for the third one, तो क्या करोगे? So you have 2/3
2/3
x3 is equal to
1/12.
1/12
x3. यही होगा ना?
Yes, sir.
So what is value of x3?
8.
Huh? 2 mango is equal to 1 banana. How many mangoes and how many bananas are there?
0.
Sorry, 2 mangoes is equal to 2 mangoes is equal to 3 mango. How many mangoes are there?
0, sir.
0. So here x3 are 0, not anything. You cannot 2/3 x3 is equal to 1/12 x3. How it can be happen? Only in one case you have x3 is equal to what? 0. So your x3 must be equal to 0. ये आप कर लो, इसको आपको मैथमेटिकल फिजिक्स में भी काम आएगा, क्वांटम मैकेनिक्स में भी काम आएगा, एवरीवेयर यू विल यूज दिस थिंग, है ना? तो आइगन वैल्यू आइगन वेक्टर तो एक ही ढंग से निकाला जाता है। चलिए, नाउ इज दैट दीज टू इक्वेशन आर सेम इक्वेशन और डिफरेंट इक्वेशन? ये दोनों को देखो तो। So I can take x1 one side, so we have minus 1/4 x2 is equal to minus, क्या होगा ये? So you have 1/12 minus 1/3 x1. So minus 1/4 x2 is equal to, that is 12. 12 minus 4 x1. What do you have? ठीक किया हूं या कुछ गड़बड़ है यहाँ पर?
Okay, sir.
It's
ठीक है,
okay?
sir.
This is 1 minus 4.
-1.
Minus
1 minus 4. Sir, it is 1 minus 4 ऊपर.
1/4 x2 is equal to,
So जहाँ पे
That-
12 लिखा है वो आप 1
वहाँ पे 1
हाँ
है.
सॉरी, वहां पर 1 होगा ना? क्या किया? वही तो मुझे लग रहा है कुछ अजीब सा है। So that value is equal to what? Minus 1/4 x1. What is meaning of that? इससे क्या कंक्लूजन निकालोगे?
x2.
is equal to x.
x1 is equal to x2. देखो तो सेकंड वाले इक्वेशन से भी सेम चीज आ रहा है क्या? सेकंड वाले इक्वेशन से भी सेम आ रहा है?
Yes, sir.
Yes.
Yes.
So both equation are same equation actually. So you have x1 is equal to x2. So what is your x1 vector? x1 vector is x1 and 0. And how many vectors you can have like that? कितने vector हो सकते हैं ऐसे?
Infinite.
Infinite vector. But all vectors are what? Parallel in nature. यही होगा ना? So what you have to do? You have to just make them normalized. And when you will normalize it, then you have x1 transpose x1 is equal to 1. Then x1 is equal to 1 upon √2. So my first axis as a unit vector. So if you are normalizing it, this is nothing but what? Identified as what? Unit vector. Okay. So इसको मैं रहने देता हूं. So let us remove this one. Let us remove this one. चलो. So you have lambda1, जिसको आप I1 भी कह सकते हो. This is much better. I1 is equal to lambda1, and that is what? MA square by 12 and the corresponding axis is x1, and that is, you can just write this x1 is equal to 1 by root 2, 1, 1, 0. This is your x1, or you can write ix alone. Anyway, so this is your thing. Now, second हमें किसके लिए solve करना है? 7 by 12, isn't it? So I will just put 7 here and I can write the equation. चलिए बताइए, what should be equation? 1 by 3 x1 minus 1 by 4 x2 is equal to
7 by 12.
7 by 12 x1. Second equation क्या होगा? Minus 1 by 4 x1 plus
1 by 3
1 by 3 x2 is equal to 7 by 12 x1, and third one is 2 by 3 x3 is equal to 7 by 12 x3. So again, x3 is equal to what?
0.
0. And from here, just you can take x1 here. So you have minus 1 by 4 x2 is equal to 7 by 12 minus 1 by 3 x1. So what is that value?
1 by 4.
7 minus, and this will be 4 na, by 12 x1. देखो मेरी अर्थमेटिक बहुत ही खराब है ना? So I have to always go with this method. कितना आ रहा है ये? 1 by 4.
1 by 4. Yes, sir.
So what is meaning of that?
Yes.
x1 is equal to
minus
minus x2. x1 is equal to minus x2. So you have to just try to calculate, and now your x2 is equal to x1 minus x1, 0. Okay. And how you can normalize it? You can easily normalize it. So that value is x2 transpose x2 is equal to 1. Again your x1 is equal to 1 by root 2. ये समझ में आ रहा है ना ये क्या करना है? या किसी को ऐसा भी तो है जिसे नहीं समझ में आ रहा है? प्लीज ऑनेस्टली बता दो, अदरवाइज बहुत प्रॉब्लम होगी आगे.
सर मैं ही हूँ.
तुम ही को नहीं समझ में आ रहा तो बताओ, कॉपी क्यों कर
अभी
रहे
तो
हो?
एक्चुअली प्रीवियस लेक्चर्स नहीं देखे
अपन
थे ना,
को-
इस वजह से मैं कुछ नहीं बोला.
अरे ये तो मैथमेटिक्स की चीजें हैं. x1
हाँ सर.
आप ट्रांसपोज कर रहे हो तो उसे क्या करोगे? कॉलम वेक्टर ले लोगे, ठीक है?
यस सर. यस.
माइनस x1 और 0 ऐसे कर ले. इसको रो वेक्टर ही लिखेंगे. x1 माइनस x1 0, इसकी वैल्यू 1 होनी चाहिए. अब हो जाएगा? बताओ. x1 इंटू x1 इज
यस सर.
x1 स्क्वायर प्लस माइनस x1 इंटू माइनस x1 इज x1 स्क्वायर इज इक्वल टू 1. सो x1 की वैल्यू क्या होगा? 1 अपॉन रूट 2. अब क्लियर है?
यस.
देखो कुछ भी हाइड मत करो, ठीक है? मुझे बताने में 2 से 3 सेकंड लगेगा, मैक्सिमम 30 सेकंड. ठीक है? हाइडिंग इज वेरी डेंजरस, है ना? अब पता चला उसके लिए बुक देखोगे, इधर उधर भटकोगे. क्लियर है?
यस. यस.
टाइम सेव करने के लिए कोचिंग ज्वाइन किए हो ना, रिसर्च
Yes,
करने
sir.
के लिए थोड़ी. रिसर्च तो आपको करना है आगे जाकर के. आर यू गेटिंग माय पॉइंट? है ना?
Yes.
अभी आपको इस पर दिमाग
Yeah.
नहीं लगाना है कि F इक्वल टू MA पर हम एनालिसिस करें. वो है, उसको अप्लाई करना है. ठीक है?
यस सर.
और नई चीजें ढूंढनी है. ओके. सो व्हाट वी हैव.
केवल प्लस
हाँ,
माइनस
बताओ.
नहीं लेंगे सर.
हाँ?
प्लस माइनस.
नहीं नहीं,
Except
नॉर्म्स
for-
है ना, सो नॉर्म्स विल बी ऑलवेज पॉजिटिव.
ऑलवेज पॉजिटिव.
ठीक है?
नो.
So I2 is equal to lambda 2. That is what? 7 by 12 MA square. And what is your x2? Your x2 is equal to 1 by root 2, 1 minus 1, 0.
जी.
चलो, last but not the least. ये सब मिटाए, उसको ऐसे ही रहने देते हैं. अब यहां क्या हो जाएगा भाई? 2 by 3 ना?
Yes,
2
sir.
by 3 MA square. चलिए देखते हैं. क्या आ रहा है 1/3 x1 minus 1/4 x2 is equal to 2/3 x1.
X1.
1/4 x माइनस क्या है माइनस 1/4 x1 प्लस 1/3 x2 is equal to 2/3 x2
X2.
and 2/3 x3 is equal to 2/3 x3. अब इन दोनों इक्वेशन को देखकर क्या लग रहा है बताओ तो?
Sir, X1 is not equal. No.
इन दोनों इक्वेशन को देख के क्या कंक्लूजन नजर आ रहा है?
सेम इक्वेशन है।
सेम इक्वेशन है? क्या बात कर रहे हो? हाँ, जरा देखो तो सेम है या क्या है?
तो अलग है।
माइनस
Same है।
1/4 x2 इज इक्वल टू माइनस 1/3 x1, यही है ना?
Yes, sir.
और दूसरा वाला क्या कह रहा है? माइनस 1/4 x1 इज इक्वल टू माइनस 1/3 x2. ये कभी
Zero.
पॉसिबल है?
Zero.
जीरो
Not-
पॉसिबल है when x1 is equal to 0, x2 is equal to 0.
X3 1.
Huh? And x3 is not
One.
1. It can be any value.
Yes, sir.
Oh. Yes, sir.
10 banana is equal to 10 banana.
100 banana is equal to 100. Okay,
100
sir.
banana is equal to 100 banana.
Yes,
So you can have take any value. Okay. So x3 is equal to x3. But if you will normalize it, then you are 100% sure that value is 1. Okay. So I3. So yes, again you can normalize. You can just get values. So I3 is equal to 2/3 ma square, and that value is equal to 0, 0, 1. So this is your principal axis. Now I will just give you homework such that you can just diagonalize this matrix in a basis of. Clear है यहाँ तक? हाँ बताओ.
लास्ट आइगन वेक्टर 0 0 1 कैसे लिखा है? 1
x1 की
कैसे?
वैल्यू 0, x2 की वैल्यू 0
ओके सर।
और x3 की वैल्यू x3,
यस सर।
Yes,
और
sir.
फिर इसे नॉर्मलाइज कीजिए,
ओके सर।
है ना? आप ऐसा फिर से करोगे 0 0 1 0 0 1 सॉरी 0 0 x3 0 0 x3 must be equal to 1. So x3 की वैल्यू क्या होगी? 1.
Well,
क्लियर है ये?
yes, sir.
यस सर।
Okay, good. So now what is your homework? Homework is that in a basis of x1, x2, x3, you have to diagonalize this matrix. और देखो diagonal term में क्या आता है. इसका मतलब समझ रहे हो क्या है ये? ये क्या लिखा हूं मैं? ये शॉर्टकट तरीका है लिखने का, है ना? ये एक्चुअली मैंने ये लिखा है, डोंट वरी. ये मैंने लिखा है x1 क्या है हमारा? 1/√2 0 0 1 1/√2 सॉरी 0 1 1 ना, सॉरी क्या लिख रहा हूं मैं?
1 1 0.
क्या लिख रहा हूं?
1 1 0।
सो 1/√2 1/√2 0. सेकंड क्या लिख रहा हूं? 1/√2 माइनस 1/√2 0. थर्ड इज 0 0 1. सो ये मैं एक मैट्रिक्स लिख रहा हूं. ओके. और लेट्स से दिस मैट्रिक्स इज सम यू मैट्रिक्स. आप डायगोनलाइज कैसे करोगे? यू विल जस्ट राइट u इनवर्स I u. इसकी वैल्यू जो देखोगे that will be diagonalized. What is u inverse? Inverse of u matrix. So you have to find the inverse of this one and then you have to write this thing. So this is your homework. देखो आप कर पाते हो या नहीं. मुझे पूरा सॉल्यूशन चाहिए लाइन बाय लाइन. ठीक है?
Okay, sir.
ठीक है, बस सिंपल कैलकुलेशन है. 3 मैट्रिक्स है, थ्री का मल्टीप्लीकेशन होगा, बट यू हैव टू फर्स्ट कैलकुलेट व्हाट इज योर u इनवर्स. क्लियर है ये?
Yes, sir.
ओके.
Yes.
So just try to do this homework, है ना? चलिए सो आई थिंक आई शुड स्टॉप हियर. अभी एंगुलर मोमेंटम, काइनेटिक एनर्जी, इसके बारे में नेक्स्ट क्लास में बात करेंगे, बिकॉज आई जस्ट वांट टू डू फिजिक्स इन द नेक्स्ट क्लास. आज की क्लास में मैं जस्ट कैसे कैलकुलेशन करते हैं उस पर फोकस कर रहा हूं. आर यू गेटिंग माई पॉइंट? सो आई विल resume this problem into next class, and we will do lot of analysis actually, and we will do some more problems into next class, and after then you should prepare for test. But अभी test में time है, don't worry. अभी मोमेंट ऑफ इनर्शिया भी करेंगे, पैरेलल एक्सिस परपेंडिकुलर एक्सिस थ्योरम, उससे भी कई बार क्वेश्चंस आ जाते हैं, तो वो भी हम लोग एक बार सीख लेंगे. ओके, सो एनी डाउट? ओके, चलो, सो टेक केयर, और फटाफट होमवर्क पोस्ट कीजिए. ठीक है,
Thank you, sir.
थैंक यू.